Okay, pre-cal, we are going to talk about graphing logarithmic functions in this video. And if you will recall, I've already spoken to you about the idea that a log function is actually the inverse of your exponential function. So I want to remind you that when we have an exponential function, and where b is greater than 1, we have a situation just like this, okay? So that's what our exponential function looks like essentially. Well, with our log function, what this would look like, it would be y equals log base b of x. And since this is the inverse, that means it's going to reflect, it's essentially going to be the reflection of this exponential function over the y equals x line. So essentially what your log function looks like is that right there. So it's got an x-intercept at 1, 0. So that is what your log function will look like when b is greater than 1. So I'm just going to highlight this so you can remember that this is the log function right here, okay? And it is the inverse of the exponential function. All right, so in the same way that f of x equals b to the x for the exponential function, is in the same way that if b is between 1 and 0, it goes in the other direction, so it would decrease from left to right. The same thing is going to be true of your log function. It is going to be different as well. So in this situation, these have a similar relationship, okay? They're going to the log function is going to reflect over y equals x because it's the inverse. So what it's going to look like, it's going to go through 1, 0, and it's going to look just like that. See how it reflects over? See, it reflects over the y equals x. So that is my log function when b is in between 0 and 1. All right, so I just showed you the log function with the exponential function so you could see that it's the inverse. That way it'll help you when you get to graphing, you'll remember what they look like. So let's fill in our information here. Our domain, remember I'm going to switch colors here. Remember I'm looking at this graph right here. My domain is now going to be from 0 to positive infinity because I only have the graph to the right of the y-axis. And this time I'm going to have an asymptote at x equals 0, which is essentially the y-axis. Okay, so now the y-axis acts as an asymptote. And the range this time is going to be negative infinity to positive infinity. It is not decreasing from left to right, it's increasing. See how that moves up right there? So it's increasing from 0 to positive infinity. There is an x-intercept at 1, 0. We do not have a y-intercept. And the end behavior, this is a little bit different for this particular problem since we've got a vertical asymptote right now. So the end behavior is occurring right here. So as x approaches positive infinity, y approaches positive infinity, and then this down here is asymptotic behavior. So for the asymptotic behavior, as x is approaching 0 from the positive direction, y approaches negative infinity. Okay, now we're going to do the same thing over here with this function. So the domain, still 0 to positive infinity. I still have an asymptote at x equals 0. The range is still negative infinity to positive infinity, and it is decreasing this time as I move from left to right. So from 0 to positive infinity, it is decreasing. It is not increasing. The x-intercept again is 1, 0. The y-intercept does not exist. And end behavior is right here. So as x approaches positive infinity, y approaches negative infinity. And then, of course, this up here is asymptotic behavior. So I'm going to call it AB because I don't want to write out asymptotic. It's kind of a pain. So as x approaches 0 from the positive direction, y approaches positive infinity. So that is just an explanation of what a graph of a log function would look like. And in the subsequent videos, we're going to look at specific examples of the transformation of the parent function.